Now I think we get the sense of and the handle of doing something a little bit more complicated. So let's go ahead and graph the function, or the graph y equals 1/2 cosine quantity 4x plus pi. So there's a couple of things that we need to recognize first of all. First of all, it's a cosine function, which has this typical look. Its amplitude is defined. We also have inside, something that tells us what its period is and also its phase shift. So to begin with, its amplitude is 1/2. So I can go ahead and mark off 1/2 positive and 1/2 negative. So I know my cosine function lives within that particular range. Its period, which is this value of b divided into 2 pi. So 2 pi divided by b gives me pi halves. So I have a period of pi halves. And that's going to be helpful because to find my key points, I need to divide that entire period into 4 equal sections. So let's take pi halves. Divide that by 4. That gives me something happening every pi eighths of the graph. So let's just file that away for now, because we also notice that we have a phase shift. So we don't know where the graph starts at. If there's no phase shift, we could say the graph starts right here at 1, 0, and then we can start marking off exciting markers of every pi eighths. Not the case here. We have a phase shift. And not only do we have a phase shift, we have a phase shift that's disguised. So if we remember from our sines graph that this value right here, we had to have it negative. So I'm going to have to rewrite this as y equals 1/2 cosine 4x minus a minus pi. Phase shift was defined as a negative inside, or as a subtraction, a minus of something. So this value now, my particular value of c is actually a negative pi. So to use that, I'm going to have a negative pi divided by my b, which was a 4. So I have a phase shift of negative pi fourths. So instead of starting here at 0, the graph, the typical cosine graph, is going to start back here at negative pi fourths. Then I can start marking off my graph. Something cool happens every pi eighths beyond that. So I'll have something here at negative pi eighths, something here at 0, another pi eighths at a positive pi eighths, and then here another positive pi eighths gives it back up to pi fourths. So there I have 5 important markers on this graph, which allows me to graph it. I know that the graph begins at a positive 1/2. So there's my maximum. Here's my 0. There's my minimum. Here's my next 0. And here's my maximum at the graph. So if I just smooth all those dots on out, and there's my graph of cosine of 1/2, amplitude is 1/2, cosine of 4x plus pi, and I see in this that I have a phase shift that calculates out to be a negative pi fourths. So I took my regular graph and I backed it up, or a phase shifted it, by a negative pi fourths. Now that wasn't too bad, was it? All right, I think I have one more after this, and we'll kind of see how we're doing.